this video I'm going to be demonstrating inductive voltage spikes. And so basically we have this is a 1.5 volt nickel metal hydride battery, 1.2 volt, and when I press this button and release it, oh, there we go, that LED blinks. And as you know, an LED requires like 2 to 3 volts. And what's going on here is when you hit the button that allows power, it completes the circuit and energizes one of the windings on this transformer, which is, I'm not using the other end. Basically, it creates the invisible magnetic fields, and those, well, they're contained within the iron, but they spread through the iron, and then they actually store energy. So almost like a capacitor, it stores energy, and then when you release the button, all those magnetic fields collapse on themselves and produce a voltage in a direction that moves current in the same way it was moving before the battery shut off. So you'll see I actually have this LED in this circuit backwards. Now if I do measure the voltage, well, if I measure the voltage with my oscilloscope, and I want to get the voltage across the inductor, which is between battery positive and one side of the switch. And the way I have it wired, actually I'm going to flip it. So this looks like it's backwards. I put the negative on the positive, and that's because the low side of the inductor will be at a higher voltage, or will be positive, and it makes more sense when you see it drawn out in a circuit. Here you can see it looks like this small spike, but I have my scope zoomed way out, so each block is 10 volts. Okay, so to be seeing anything approaching 10 volts, and we actually have 14 volts peak, and then it kind of tapers off. So this is a pretty big inductor, and that's why we're seeing such large spikes. And then if we actually, since it's a transformer, we could hook up here, and you get higher voltages since you have the transformer effect. But yeah, this is one of the reasons why it's important. Sometimes on toy motors you'll see a little capacitor across the two terminals. That's because whenever the driving transistors switch off, you'll get a voltage spike, 10 volts, something like that, I don't know, and that could damage, it'd be like a negative voltage, and that could damage the transistors.